Okay, what is the distance of a geostationary satellite from the Earth's surface, given the mass of Earth, radius of Earth, mass of satellite? What? What's the distance of the satellite from the Earth's center? It didn't give me any information. Give us the mass, the radius, mass of satellite. That's it. What about the gravitational field strength at that point? I will need that value to find the distance. Yeah, for example, like this formula. If I want to find the distance r, I will need the gravitational field strength. Is there any information on that? No. Oh my god. So you give up. Many students give up. They say information not enough. Impossible to solve these questions. Aha. So this is where this question gets tricky. Okay. So you see, look for keywords. Why suddenly he talk about geostationary satellite? So it must be related to the satellite. Okay. Look at the satellite. Then talking about satellite, we learn about period, isn't it? Do you know about the period of satellite revolve around the Earth in one revolution? How long it takes for the satellite to make one revolution? How long it takes? What is the period? He said geostationary. Geostationary, that means what? That means always on the same spot, referring to the geographically location. That means how long it takes for the Earth to rotate. Yeah, how long it takes? Let's say the satellite is over here. Geostationary. Yeah, that means geostationary. That means he always fixed to this location. Yeah, this is what we call geostationary. Geostationary. Let's say if this place is Kenya, right? So when the Earth make a rotations of what? In one day, yeah. Let's say the period of the Earth is 1 day. Make a revolution make a rotation in 1 day. Make a complete rotation in 1 day. The satellite also takes that long, that 1 day to travel around the Earth for one complete circle. Also 1 day. Understand? So that means the period of Earth, this is the Earth. This is the Earth. The Earth take 1 day long to make a rotation. So the satellite also take 1 day to make a complete revolution around the Earth. Because it must be always geostationary to Kenya. Understand? This is the satellite. Okay, so you also make it also take 1 day to rotate around the Earth. Okay, so we know this about 1 day, even though it's not given in the questions, but this, so if not enough information in the questions, that means it needs something from your general knowledge. You need something from the general knowledge, and normally the general knowledge for this chapter is about this 1 day, yeah, for the Earth rotation. This is very basic things. Okay, everybody should know. So we use this formula, period equal to this one. You see, if you use period, you also can find the r. Okay? Not necessarily have to use the gravitational force or gravitational field strength to find the r. You also can use period. Use this formula, 2 pi square root r cubed over gm. Okay, so that's it. That's it for these questions. So period is 1 day. We must change to second. 1 day is how many? 24 hours. 1 hour has 60 minutes, and 1 minute has 60 seconds. Okay, let's calculate. 24 times 60 times 60. 24 hour, 1 hour 60 minutes. Yeah, 60 seconds. Okay, correct. So 1 day is actually equal to 86,400 seconds. Do you know that as you procrastinate all this while, the time ticking along for 1 day, yeah, each day will complete this amount of seconds. Do you know how much time have you wasted doing nothing? Okay. All right, so okay, so this so okay, let's use the formula period 2 pi square root r cubed over gm. R is the distance of satellite to the Earth center, because we also want to find this R distance of satellite to center, right? Not to surface one. This one also need to pay attention. Is it to the Earth surface or is it center? So it's not surface. If surface, it is using H. Understand? It's using H. This one to Earth center means it is using R. Understand? Using R. We need the R value. Yeah, R value. So R. So which is this one? This one is correct. The R. The R is actually the radius of Earth plus H. But we don't need to bother about the H anymore, because we can directly find the R from this equation. No need to find the H anymore. Okay, it's actually R is actually the radius of Earth. Yeah, I want to draw it out. Yeah, this is the this is the radius of Earth, and this is the H. Understand? Here is the H. The R is the whole thing lah. What is this? R is the whole thing. But we don't need to bother about the H. We from this equation directly can find the R. Okay. And then another thing is what is this mass? It gives us two masses. We have mass of Earth and then mass of satellite. This is just to confuse you. Okay. Remember, what is this mass? Look at here, the mass here. This mass is the point mass. You see the big M there? Big M is the point mass. M is the point mass. Mass of Earth. Where's the mass of satellite? Mass of satellite is already being cancelled. You see? Mass of satellite is already being cancelled. So we're not using the mass of satellite. We are going to use a point mass. Mass of Earth. Understand? M. So this M is the point mass. Which is the Earth. Not the satellite. Satellite mass. No need to use. No need to use. Don't use 100. Yeah, you use it, then you are doomed. Okay. Mass of satellite already been cancelled during the formula derivation. Already been cancelled. So this is the point mass of Earth. Okay. So okay, continue to find your answer. Let's find out your answer. So this is 86,400 seconds. So 2 pi, and then you got R cube over G. What is the G value? Okay, what's the G value? Okay, what's the G value? G value you can find from a list of constant. G value, gravitational constant, which is 6.67. 6.67 exponent negative 11. Negative 11. So that's it. Okay. 6.67 negative 11. 6.67 negative 11. Negative 11. So okay, so what's the mass of Earth? Not mass of satellite, mass of Earth, So okay, 5.97 exponent 24. Okay, 0.97 exponent 24. Okay, so find out the R. Let's calculate the R. Okay, let's calculate 86400 by 2 pi, and then I square the answer. and multiply by 6.67 exponent negative 11, multiply again, exponent 24, and then cube it, square, oops, so it should be, so oops, okay, so I got the answer is 4.223 exponent, how many? 0, 1, 3, 3, 6, 7 meter. Okay, is there any answer? Oh, this one in kilometer, meter we don't have. Okay, so we need to change to kilometer and see. Change to kilometer. So this is a 4300 exponent 7 kilometer. Okay, I put a kilo there. That means I need to put a negative 3 there. Okay, because kilo itself is positive 3. Understand? Positive 3, so I need to put a negative 3 to balance out lah. It's like you cut it off. You understand? It's like you cut it off this one. It's like back to meter. Okay, never mind. Okay, so finally it becomes answer is 4.233. Not 233, it's 223. Yeah, sorry, 223. Exponent 4 kilometer. So is there answer? Is there an answer? Exponent 4 kilometer. Yes, that's the answer. Very simple. Okay. All right. So that's it for these questions. General knowledge. Period of satellite is 1 day. Use this formula.